Welcome dear students, welcome to the final video for this chapter chemical kinetics. Today here in this video we are going to conclude the chapter. So we'll be discussing the remaining part whatever were left from the last video. So now let's start. We will be starting the video with the integrated rate equations where we will be trying to derive the integrated form of rate equations for zero order reaction and for first order reaction. So let us start. So now for a zero order reaction we have to derive the rate equation, the integrated form of the rate equation we have to derive it here. So let us start and let's see how it is done. For this, let us first consider a general reaction where R is changing to P. Then the rate law we are to write. So first of all, we will write the average rate, that is equal to minus dr by dt, which was equal to again K concentration of R raised to the power 0. Now the power is raised here 0 because it is a zero order reaction, and order of a reaction, if you remember, it was the sum of the powers raised in the rate law expression. So if we are writing the rate law expression for this, it will be K R naught. So now if you are just rearranging it, you will get d concentration of R by dt is equal to, just substitute this minus that side, you will get minus k, and since r is raised to the power 1, so that will become only 1. R is raised to the power 0, so that will become 1. Now do a cross multiplication, you will get d concentration of r is equal to minus k and then dt. अब इसके बाद क्या करो, जस्ट एक इंटीग्रेशन का साइन लगा दो यहाँ पर, जस्ट ब्रिंग इंटीग्रेशन, व्हाट यू विल गेट हियर, you will get it as concentration of R is equal to minus KT and plus I, where I is the integrating factor. So now you take that, जब ये reaction शुरू ही नहीं हुआ है, suppose you have considered a reaction R is changing to P, now you consider that the reaction has not started. तो reaction अगर शुरू नहीं हुआ तो मतलब T का वैल्यू कितना होगा, 0, और concentration of R कितना होगा अगर reaction शुरू ही नहीं हुआ है तो concentration of R तो उतना ही रहेगा जितना आपने शुरुआत में लिया था. So your R will be R naught. So now just substitute these values in equation 1 and let us see what we get. So in equation 1, if we substitute these values, we will get like concentration of R is equal to minus KT plus I. This is your value. So if you are substituting these values, you will get concentration of R is equal to, this will become 0 because K into T is 0 and I is your I. So since the reaction has not started, then T was 0, so your R is given as R naught. It means that the value of I is R naught. This is your equation number 2. So now putting the value in equation 1, what we will get, let us see. We will get concentration of R is equal to minus KT plus this one concentration of R naught. To substitute it, you will get it as minus KT is equal to concentration of R minus concentration of R naught. Then now derive the value of K. You will get minus K is equal to concentration of R minus concentration of R naught by T. Just do one thing, just revert it. If you are just reverting it, what you will get the value of K? You will get it as K is equal to concentration of R naught minus concentration of R by T, and this is known as your integrated form of the zero order reaction. So now this one you have to watch the video and you have to write it from the video, like let us consider a general reaction, consider a general reaction, consider a general reaction. This is your R is changing to P, then the rate is given by this one, this. Then if T is equal to 0 and this one is equal to 1, then equation 1 implies, and these are the values that you have substituted, and this expression that you have obtained, this is known as your the integrated form of your zero order reaction. So now next we will be trying to derive the integrated form of equation for our first order reaction. Let us see for first order reaction. So similarly for first order reaction also, let us consider a general reaction. Writing will be same. Consider a general reaction like R is changing to P, and for this reaction also your rate will be given as rate is equal to minus dr by dt. This is your concentration is equal to K concentration of R. This time not 0 because this is your first order reaction, and the power here will be 1. So once again you just make a basic arrangement here, and the arrangement will be, how will you do the arrangement? Just this will be you writing d concentration of R by concentration of R is equal to minus K dt. This is how you are to arrange here. Means this R you have got it here, and this dt it has shifted that side. So now put an integration sign here, integrate it. Then if you remember, integration of dx by x is equal to log x. So here we will be writing ln concentration of R is equal to minus K T. Once again the same thing, minus Kt and then plus I. And once again you just imagine that if the reaction is not started तो T is equal to 0 हो जाएगा, concentration of R जो हो जाएगा वो हो जाएगा concentration of R naught, मतलब शुरुआत में जितना दिया था उतना. So now put this value, substituting these values in equation 1, then substituting in equation 1, what you will get? You will get it as ln concentration of R naught is equal to 0 हो जाएगा ये, प्लस आई, मतलब आई इक्वल टू ये मिला, ये इक्वेशन नंबर 2. नाउ देन विल राइट substituting in 1, what we will get? Substituting in 1 we will get ln concentration of R is equal to minus Kt, और ये कितना आ जाएगा प्लस ln concentration of R naught होगा ये. वहाँ से मिल भी सकते हैं, इसको उठा के करना, that will be Kt is equal to ln concentration of R naught minus ln concentration of R. So your K will be equal to ln concentration of R naught minus ln concentration of R by T. Now if you remember your formula, log A minus log B, then log A minus log B is equal to log A by B. So this will be equal to ln concentration of R naught by concentration of R by times T. So now if you are to convert this ln from ln to log, you have to multiply by a factor, that is 2.303. This will be equal to 2.303 by T log concentration of R naught by concentration of R. This is your integrated form of rate equation for your first order reaction. So these are your two integrated form for zero order and for first order reactions. Now from this again we have to do one basic thing is there, that is a half-life of a reaction. Now half-life of a reaction, it is defined as the time in which the concentration of a reactant is reduced to 1/2 of its initial concentration. मतलब अगर एक reaction है मान लो जो कि A से B बन रहा है, अगर इसको A से B होने के लिए T टाइम लग रहा है, तो T हाफ का मतलब है कि ये A जो तुमने लिया था ये A by 2 कब हो रहा है. That is defined as your half-life of a reaction. So now this half-life of a reaction, it can also be determined from the expression that was given there in the zero order reaction for first order reaction. इन दोनों order of the reactions के लिए तुम्हारे ये जो हाफ लाइफ टाइम होता है ये अलग होता है. जैसे मान लो एक जनरल रिएक्शन है, मान लो जो कि A चेंजेस टू B है. अब इस A चेंजेस टू B अगर ये जीरो ऑर्डर था तो इसके लिए K का वैल्यू, अगर मान लो मैं पीछे जाऊँ और पीछे से दिखाऊँ तो जीरो ऑर्डर रिएक्शन के लिए what was your value of K? Your value of K was K is equal to concentration of R naught minus concentration of R by T. So let me calculate this one. So here the value was, suppose K is equal to concentration of R naught minus concentration of R by T था. तो अगर मैं इसको सब्स्टिट्यूट करके यहाँ से T का वैल्यू निकाल लूँ तो T क्या हो जाएगा, concentration of R naught minus concentration of R by K हो जाएगा. जस्ट एक बेसिक सा सब्स्टिट्यूशन किया है, अरेंजमेंट इधर वाला उधर इधर वाला इधर. अब बोला है कि रिएक्शन आधा हुआ है, मतलब टाइम हाफ. सो व्हेन, सुनो ध्यान से, व्हेन t इज इक्वल टू t हाफ, तो क्या होगा, जो फाइनल कंसंट्रेशन है, दिस इज योर फाइनल कंसंट्रेशन, ये फाइनल कंसंट्रेशन इनिशियल वाले का आधा होगा. मतलब योर कंसंट्रेशन ऑफ R विल बी इक्वल टू concentration of R naught by 2. Why R naught by 2? Because since the time taken is half, तो मतलब जितना हमने शुरुआत में लिया था उसका आधा हुआ है. तो ये सारे वैल्यूज इसमें पुट कर देते हैं. दिस इज योर इक्वेशन 1. then substituting the values, what you will get, t will become t half, then it will have R naught minus concentration of R naught by 2 by k, then that will be equal to, I'm going to write it directly, you will get it as, this will be 2k, and above you will get concentration of R naught. Now how you got this? I'll show it to you, sir. This is k, this you will get the LCM as 2, which will get 2 concentration of R naught minus R naught. So this one you will get the final value. So this is your expression for your T half, when you have T half is equal to concentration of R naught by 2k. This is the expression for the half-life period of a zero order reaction. Now if you see here, what you are looking into it, that this 2 and k, they are a constant value. So from here you can see that in case of zero order reaction, T half is directly proportional to your initial concentration. मतलब जो आधा टाइम है वो इनिशियल कंसंट्रेशन के ऊपर डिपेंड करेगा कि हाफ टाइम कितने देरी के बाद आएगा. So this is your expression for your zero order reaction, and this one also you have to copy it down in your copy by pausing the video. Now let me do it for the first order reaction. Now for first order reaction, once again consider a general reaction R is changing to P, and for this, if you remember from the previous video, from the previous slides, you can see K was equal to 2.303 by T, and then log, then this was concentration of R naught by R, concentration of R. Now if you once again substitute this, T will be equal to 2.303 by K log, then concentration of R naught by R. Then once again here, if T is equal to T half, then your concentration of R, this final concentration, it will be the half of initial concentration, मतलब R naught by 2 होगा. And now if you are going to substitute your value here, so let us see how we will substitute in what we get here. We will get T half is equal to 2.303 upon K, then log. Now your concentration of R naught will be concentration of R naught by concentration of R is R naught and divided by 2. Now if you see this 2 will be cancelled out, you will get 2.303 by K, and you will get log 2. Now log 2, the value of log 2 from the log table, you will get it as 2.303 by K. The value of log 2 is given as 0.301. So now this is multiplied. If you multiply these two values, you will get 0.693 by K. So now in this case, you see, पहले वाले केस में क्या आया था? Your first case, for your zero order, in case of your zero order, you had the value of T half as concentration of R naught by 2K. This was for your zero order, and now this is for your first order. First order में देखो T half का relation, इस relation में कहीं भी initial concentration नहीं है, but in this case you have your initial concentration. It means that when the reaction is a first order reaction, your half-life of a reaction, it does not depend on the initial concentration, but when you have a zero order reaction, your half-life depends on the initial concentration. Now next is your temperature dependence of a reaction. Means how a reaction is dependent on temperature. If you remember at the initial stage of the chapter, starting of the chapter, I said that the speed of a reaction or the rate of a reaction is dependent on three values. First was concentration, then it was temperature, and lastly it was your catalyst. Now we will be moving to the temperature dependence. Now temperature dependence for a chemical reaction with rise in temperature by 10 degrees Celsius. By 10 degrees Celsius, the rate constant is nearly doubled. Means the value of K that we were calculating there, if suppose if the K for a particular value is X. Suppose if this K for a temperature of 5 degree is X, then when the temperature is reached by 10, means if the temperature is 15 degree, then this K will become twice X, and this is what temperature dependence is said. The temperature dependence on the rate of a chemical reaction, it was given by your Arrhenius equation. It was a Dutch chemist, which one of, but Swedish chemist Arrhenius provided the physical justification. Means finally it was given by Arrhenius. So this is your equation. The equation is given as K is equal to A e to the power minus EA by RT, where this EA means the activation energy. You'll see it here, where this A is your Arrhenius factor or the frequency factor. It is also known as a pre-exponential factor. It is a constant specific to a particular reaction. R is your gas constant and EA is the activation energy, which is measured in terms of joules per mole. So this is your temperature dependence of a reaction. Temperature dependence of a reaction is given by this value, where K is equal to A e to the power minus A by RT. Now, next is your effect of a catalyst. Now, what is the effect of a catalyst? This was also seen. Like a catalyst, first of all, we have to know that what is a catalyst. So, a catalyst is a substance which alters the rate of a reaction without itself undergoing any permanent chemical change. मतलब कैटलिस्ट किसी भी रिएक्शन में एक ऐसा चीज़ है, जैसे मान लो ए को अगर मुझे बी बनाना है, तो ए अगर खुद से बी नहीं बन रहा है, तो कैटलिस्ट एक ऐसा चीज़ है जो इसको मदद करता है ए से बी बनने में, लेकिन कैटलिस्ट खुद में कोई चेंज नहीं आएगा. A catalyst is a substance which alters the rate of a reaction without itself undergoing any permanent chemical change. मतलब जो catalyst यूज करेंगे वो catalyst किसी भी तरह से रिएक्शन में इन्वॉल्व नहीं होगा, मतलब वो सिर्फ इनिशिएट करेगा रिएक्शन को. For example, MnO2 catalyzes the following reaction so as to increase its rate considerably. Just omit this. Now, the action of the catalyst can be explained by intermediate complex theory. अभी intermediate complex theory क्या है ये समझो. According to this theory, a catalyst participates in a chemical reaction by forming temporary bonds with the reactant, resulting in an intermediate complex. This is a transitory resistance. देखो ध्यान से यहाँ देखो कैटलिस्ट क्या करता है, कि किसी भी रिएक्शन को अगर ए से बी बनना है, तो अगर ए यहाँ पर है तो इसको पहले ऐसे ऊपर उठना होगा. आफ्टर दैट इट विल ब्रेक डाउन टू बी. मान लो ये ए है तुम्हारा एंड दिस इज योर बी. तो एंड दिस इज योर मीन्स ये जो यहाँ से लेकर के यहाँ तक उठा है, इसी उठने वाले को हम लोग कहते हैं एक्टिवेशन एनर्जी. नाउ यू सी in this graph that is shown to you. Now here in this graph, if you see it, this is your reactant phase and this is your product phase. Now this was the energy which is required in the absence of catalyst. जब catalyst नहीं था तो देखो energy यहाँ तक थी, लेकिन जब एक बार catalyst आ गया तो देखो energy कहाँ पहुँच गया, कम हो गया है. तो catalyst what is that? It lowers the activation energy, जिसकी वजह से अब देखो कोई भी चीज़ है जो जितना ऊपर चढ़ेगा उसको नीचे उतरने में उतना समय लगेगा. So simple technique is followed here that if a reactant the activation energy is lowered, वो product जल्दी से आ जाता है. So this is the effect of catalyst on activation energy, and this one also you have to copy it from the video exactly the way it is written here, like here also and in the previous slide also. This is the thing, and you need to draw the graph also. Now the last topic is here, the collision theory of chemical reactions. Collision theory of your chemical reactions. Collision theory of chemical reactions. This is here. Now, according to this theory, the reactant molecules are assumed to be hard spheres. मतलब माना जाता है कि अगर दो reactant molecule में react कर रहा हूँ, मान लो H2 और Cl2 को react कर रहा हूँ, तो H2 भी एक बॉल की तरह है, Cl2 भी एक बॉल की तरह है. Now, अब इन दोनों को अगर HCl बनाना है, तो ये कहा गया है कि इन दोनों को आपस में टकराना होगा. They will have to collide with one another. So, possibility to occur when molecules collide with each other. The number of collision per second per unit volume of the reaction mixture is known as the collision frequency. मतलब एक सेकंड में कितने बार वो कोलाइड कर रहे हैं, that is known as the collision frequency. Another factor which affects the rate of a chemical reaction is activation energy. जैसा कि हमने पहले पढ़ा यहाँ पे in this equation. Here, so we saw that activation energy जो है ये EA जो है ये एक रोल प्ले करता है. So this is the same thing what there it is explained that this for a biomolecular elementary reaction, suppose ये एक reaction है मान लो जहाँ पर from A to B it is changing, A plus B is changing some product. So here the rate of the reaction it is given by this one. मतलब ये final term है कि collision theory किस तरह से काम करता है. Rate is equal to Z AB e to the power minus e a by RT, मतलब ये भी एक्टिवेशन एनर्जी है. So where ZAB represents the collision frequency of the reactant, मतलब A और B आपस में कितनी बार टकरा रहे हैं उसका फ्रीक्वेंसी है 1 सेकंड में. In 1 second, how many times they are colliding with one another, that is given by ZAB, and A and B and e to the power minus a by RT represents the fraction of molecules with energies equal to greater than E. Comparing the above equation with Arrhenius, we can say that E is related to. अब देखो Arrhenius वाले में क्या था? What was your Arrhenius equation? If you see that the Arrhenius equation that we came to know, Arrhenius equation was in place of your ZAB. In place of your ZAB, you had your A. It was K is equal to A e to the power minus E A by RT. तो यहाँ देखो अगर इन दोनों को मिलाते हैं, यहाँ देखो ये A है और यहाँ देखो ये ZA है. तो मतलब कहाँ है कि किसी भी अगर रेट इक्वेशन को हम मिलाना है तो आर्हेनियस इक्वेशन जो है, सॉरी आर्हेनियस फैक्टर जो है, दैट इज योर कोलिजन फ्रीक्वेंसी. Now let us try to do this question that in a reaction A and B, the initial rate of reaction was measured to be R naught for different initial concentration of A and B as given below. तो अब हमें इस क्वेश्चन को सॉल्व करना है. First of all, for solving this question, what we are to do is that we have to write the rate law. अब rate law क्या कहता था? R is equal to K concentration of A raised to the power x and concentration of B raised to the power 1. This was your rate law. So now from these three conditions हमें ये rate law में put करना है. एक एक कंडीशन पुट करते हैं. दिस वन, द फर्स्ट वन, जो पहला वाला है, let me mark and show you. These value, they are the values of your R. This is R1, R2, R3 और ये इनके अलग अलग concentration है. तो let me write them and I'll show you that how we have to solve it. Let's see. In place of R, let us write this first value. क्या है? 5.07 multiplied by 10 to the power minus 5 is equal to K. अब देखो हमें concentration of A कितना दिया? That is 0.2. Now we don't know what is the value of x, so we'll write it in x. B is your 0.3. This is the first one. ये पहला वाला है. Now come to the next one. For your next case, it is 5.07 into 10 to the power minus 5, which is again equal to K concentration of 0.1 and K concentration 0.2. अब इसका भी ये y होगा and this is also y. Here to x. Last one is 1.43 into 10 to the power minus 4 is equal to K concentration of 0.05 by 0.4 and this is again your y and this is also your x. So now we have to solve this question because here we have been asked that what is the order of the reaction with respect to A and order of the reaction with respect to B. Now we have to solve this equation. Now how we are to solve this? We have to solve as we have solved in our class 10, how three equations are solved. This is my equation 1, this is my equation number 2 and this is my equation number 3. Now how we have to solve? Now we have to solve them in such a way that one of the power gets cancelled out. Now how and which one will get cancelled out, that one we have to see it, we have to check it and we have to determine from the given values. Now let us see how we can do. So let us divide equation 1 by 2. Now if we are dividing equation 1 divided by equation 2, what we will get is 5.07 into 10 to the power minus 5 by 5.07 into 10 to the power minus 5 is equal to K. We have to divide the two equations. K by K, this will be 0.2 concentration of x. This will be 0.1 concentration of x. Then here you have this one. Here one mistake is there. Sorry, this is a problem here. Here you see when the value of, see here, when the value of A was 0.20, the concentration of B was 0.1 in the second case. But here what I did is reverse. It will be 0.2 here, this will be 0.1 here, this will be 0.1. So now here, while solving this, we have to take those equations which will cancel out any of the variables. So if I am dividing 1 by 2, I will get 0.2 power x. Then just write the remaining one. The remaining one will be 0.3 to the power y, and this will be your 0.1, and that will be concentration of y. Now this value will cut off, this value will go. Now if we are to solve, on the right side you will be getting it 1, and that side you will be getting 0.3 to the power y by 0.1 to the power y is equal to 1. Now this one I can write as 3 to the power y is equal to 1, because see 0.3 by 0.1, this one I can write 3, 0.3 by 0.1 to the power y, I can write it in this way, is equal to 1. So now 0.3 by 0.1 means 3 to the power y is equal to 1. Now here 3 to the power y is equal to, this one I can write as 3 to the power 0. Now when both sides the bases are same, it means the powers are equal, so y will be equal to 0. Now we got the value of y as 0. So putting the value of y in any of the equation, we can put the value of y and we can determine that what is the order of the reaction. Now you see this y, it is with respect to b. See, in case of b we have written it as y. So the order of the reaction with respect to b is 0, and you have to put the value of y in any of the equations, and you have to determine the value of x, and you have to conclude it writing that the order of the reaction with respect to a will be this one. So this was your one more question is there, that was your question. Based on that, now we have to calculate the half-life of first order reaction from the rate constant which is given below. So now how to calculate the half-life for a first order reaction. Now if you turn the video, if you go to the previous section, you will get that the half-life of a reaction when the order of the reaction was first order, you see that it was only given as T half is equal to 0.693 by K, and these are the values which are your K values. And now why only unit is K? Because they are all first order reaction. In case of first order, your constant only is related with the time. So now in all the cases you just have to calculate the value of T half by just putting T half is equal to 0.693 by 200. This is for number 1. The calculating